In this video, I'm going to show you some complex conditions using SQL's select statement, and I'm going to use the HR database that we created in a previous example or used in a previous example to do this. And I just want to show you some of the results that we get when we're doing these comparisons. So the first thing is select star, and that just means I want all columns from employees, which is the table we're primarily going to use here, where, and I'll just start with salary. Salary is greater than or equal to 5,000. When I run this statement using the execute statement button, I get this result. And let's just click here to sort this. So if you click on the column heading, you can sort it, and you notice that nothing is below 5,000. So that's what this comparison operator is doing for us. The other example that we had in the previous slides was that we wanted to check the job ID and make sure that we could list everybody in the IT programming job. And if we run this query, we see that there are 5 people with that job ID, and their salaries range from $4,200 to $9,000. What if we want to compare a date? In MySQL, date comparisons are a little strange. So let's look at the hire date. We want the hire date less than or equal to, and in MySQL you have to do year, month, day. So that format has to be there every time you use it. So I'm going to say 1997, and the month is going to be December, so 12, and the day of the month is 01. So when I run this, now I see I can sort by hire date and note that nothing is after 1997 on December 1st. And if we change that, let's say August 1st, if I change that and sort that, notice that some of those initial items that I had in the previous one have disappeared. So always remember that it has to be a 4-digit year, hyphen, a 2-digit month, hyphen, and a 2-digit day. Now there are also some things that you can do with dates. So if you have it in an alternate format, you can change that. So a string toDate function. In a string toDate function, you can do this. You can say, let's say the month, the day, and the year, the 2-digit year, and then we say the format of that would be the month, %m, hyphen, %d for the day, and %y for the year, the 2-digit year. And if we run that, we should see that that also is looking at December 31st, less than or equal to December 31st. So we grabbed a December 30th, 97, and so forth. So you can do some more advanced string comparisons with dates using string toDate or str2date. You can look up these format masks, so month, day, year. If this was a capital Y, for example, we would have to put 1997 for the 4-digit year. So those are some date comparisons. The next thing we would look at is commission percent is null. So let's run that and let's see if, well, all of the employees have commission. Oh, I misspelled it, I think. There we go. All of them have commission except one person. So this lists the person who does not have a commission percent listed. If I change this and try to say equals null, let's see what happens. We get no results because, again, null is not a value, so it doesn't know how to evaluate this. So you have to say is null rather than equals null. Is null rather than equals null. So now let's do some more complex conditions. Let's say where the salary is greater than or equal to 5,000 and the hire date is less than or equal to, again, it's 4-digit year, 2-digit month, and then 2-digit day in my SQL. So select star from employees where salary is greater than or equal to 5,000 and the hire date is less than or equal to December 1st, 1997. So we run this and we get a good list of people there. For the next couple of these, I'm going to copy and paste so we can see a little more about what's happening here. So this one, let's check the salary is less than or equal to 5,000. And the salary is, or the salary is greater than or equal to 10,000. So I run this and I see that I get 68 rows returned, and it tells me that at the bottom of the screen. 68 rows returned for this particular query. If I just flip these signs from less than to greater than and from greater than to less than, remember in the previous video I said this would return everything that's in that employees table. So if I look, it returns 107 rows. I could also put this in parentheses and add not to the front, and this should return nothing. Because if this part returns everything, negating it with the not operator would cause it to return nothing at all. Another thing that we looked at in the previous video was the employee's last name. So let's look at the last name field where the last name is Taylor or the last name is Smith. And when I run that, I get a list of 2 different people named Smith, 2 different people named Taylor. So let's also add or last name is equal to King. When I run that, now I've got a list of 6 names here to do that. But remember what I said in the previous video, you can also use the in operator. So where the last name is in, Taylor, comma, Smith, comma, King, and that's a much shorter version and it's much easier to read, but it returns the same data. So those two are equivalent operators. So those are some string comparisons that we did. Now let's look at at some aggregate functions. So select, let's say department ID, comma, average salary. And I'm just aliasing this field from employees, group by. Actually, I'm going to leave that out, so I'm going to order by department ID, ascending. Let's run this and see what happens. Look at the error code that comes up. It says in aggregated query without group by, expression number 1 of select list contains non-aggregated column employees.department ID. This is incompatible with SQL mode, only full group by. So what that means is it says expression number 1, and it's talking about this right here, this expression right there. Everything that is not part of an aggregate function must be in a group by. So now our full statement is select department ID, average salary, from employees, group by department ID, order by department ID. So if we run that statement, now we see the list as we saw in the slides. And another thing that we have to consider here now is if we want to do a comparison on that average salary, we could try a couple of things. So let's try where salary less than or greater than or equal to 10,000. Now I want you to notice what happens here. So this is not the result that we want, but let's take a look. It shortens this. The reason for this is the where clause is evaluated by every row. That means that it's eliminating every row from the result set that is less than 10,000. So that also means that this average is only averaging things that are greater than 10,000. So this is an invalid condition. So we don't want that. We just want it to display where that average salary is greater than 10,000. So let's look at that and try to do that here. So we run this statement and we get an error at the bottom of our screen. It says invalid use of group function. And what that means is that this is a group function, an aggregate function. We cannot do that with a where clause because, again, the where clause evaluates row by row. So we need to change this to having. And our order is important here, so the having has to go after the group by. So now we run this, and we should get the values that were presented in the slides. So department ID 70, 10,000, 90, and 110. They're all above. The averages of everything are above. So it's very important to realize that the where clause is eliminating rows, whereas the having clause is eliminating rows after they are aggregated, not before.